Hey guys, it's Mr. Ray here. We're going to look at another type of quadratic word problem. Uh, this type we're going to do today is called projectile. It's probably the most common type of word problem, and it's also should be the most straightforward. One of the reasons for that is every time you get a projectile word problem, you're going to be given the equation, so you don't have to make it. And the types of questions that can be asked are fairly predictable. So I'll go through those. I'm going to do a multi-part question that's actually on your uh, word problem uh, document that is on Google Classroom. This will be question number 12. So if we look at question number 12, it's got multiple parts. Let's start off with the beginning. The height of a flare above the ground is a function of the time in the air. So t will be your input variable, like your x, and the h will be your height. And it will always tell you the units in the question. So for example here, time is measured in seconds and height is measured in meters. Okay, and that's important when you answer with a word answer, because you just don't give the number, you always give the units as well too. Okay, so the height of the flare is represented by this equation, which I've written down here. So this is question number 12 from the handout, in case you didn't notice. Now there's a series of questions here. Now it's always really advantageous to draw a little sketch of what's going on. So in this case, you've got you've got your t-axis for time. That's always going to be along the bottom. Your height along the side, because that's vertical. Now, the thing about word problems is there's restrictions on the variable. And for example, when you're firing something in the air, the height has to be, it's going to be above the ground. It's not going to go straight into the ground underground. It's going to, when it hits the ground, it just stays there. Okay. So in terms of the height, I'm not going to worry about any negative heights down here. And also the time has to be positive. So I'm only looking at the right side or the positive side for time, nothing over here. So this this graph for this relationship, you can basically draw in one quadrant. H is positive and T is positive. And projectiles are, the reason why they're so popular for quadratics is because when an object goes up in the air and comes back down, it always follows a parabola. And since it goes up and comes down, that's a parabola that opens down. So the equation will always have a negative for your a value. That's a given. Now, some of these other things, let's look at these numbers. The first two aren't that important, but it might be of interest. So this negative 4.9, you'll see this a lot in projectile questions, and you'll probably say, well, why is that such a popular number? Sometimes they round it to negative 5, but negative 4.9 is actually that relates to the gravitational constant on Earth. Okay, so that's the role that gravity has to play on this. On another planet or the moon, this, something goes up there, comes down, this number would be different because of gravity being different. This number here is actually the initial speed. So when something gets fired up in the air and comes down, this tells you that the initial speed was 92 whatever. So in this case, the initial speed was 92 meters per second. Okay, so those two, I'm just telling you that out of interest. Some of you may find that interesting. This one here is important, and we've talked about that. This is like your C value in the equation, and the C value in standard form equation is always the initial value, so the initial height in this case. So whenever you're sketching your diagram, you can pull that number out and say, well, that was the height when t was 0, and you could easily plug t equals 0 here. These go to 0, and you're left with 9. Now the rest of it, this is a parabola that's going to go up. Sorry, it opens down, but it's going to go up initially. I have no idea right now how high this is going to go or how far, but I'm just going to draw, a parabola like that without any scale here. I mean, the 9 is probably not a great scale, but just, that's the value at the beginning. That should be right there. Okay. So that's how you start, okay? And the diagram is always useful when they ask a word question. So for example, if we go to the first question here, what's the height of the flare after 3 seconds? So that basically in this question, they want to know when t is 3, meaning 3 seconds, what is the value of h? So this is just plugging in the value into the equation. So in this case, h is equal to negative 4.9. Replace the t with 3, so 3 squared plus 92t, which is 3, plus 9. So we just replace t with 3 in the equation for the height. And you go ahead, so I'll just do this quickly. So this term works out to negative 44.1. This works out to 276, and the 9 is still the same. If you combine those, you get 240.9. Okay, and I didn't do any rounding here. I just calculated with the numbers that it came to. So this is actually exact. Okay, and the units here, like we said, height's measured in meters, and so that's our answer. The height after 3 seconds is 240. So I have no idea what this scale looks like, but I could say after 3 seconds, the height was 240.9 meters. And obviously this scale is way off, but this just gives you an idea of what did we just find here? We found the height when t is 3. Okay, now word question means word answer. Even though this is pretty meaningful, still want to say now. So answer the question back basically the way it was asked. What is the height of the flare after 3 seconds? Therefore, after 3 seconds, the flare was 240.9 meters high. Okay, now you might say, well, can I round that to 241? You could. There was no specific rule in the rounding here. I would be tempted just to leave it the way it is. I mean, it's exact. Normally, you wouldn't put any more than 2 decimals, even if if your answer was running on with digits. The most I would put in your answer would be 2 decimals after this. 1 is pretty safe, but I'd probably leave it like that. Okay, next question. What's the maximum height reached by the flare? Okay, so the word, as soon as you see that word maximum, okay, the warning bell should go off, and you say, oh, maximum of a parabola, that's the vertex. So even if you didn't put that together with just the words, you can go to your diagram and go, okay, the highest height was right there. Oh, look at that, it's the vertex. Okay, so it's basically asking, what is the height? What's the maximum height that this flare gets to? So how do we get that? We have to find the vertex. So we're given the equation in standard form. So normally I would say, just complete the square, get your answer. It's got the, it'll have both the time it took to get there and the height in the vertex. In this case, because of the, looking at that equation, if you're going to divide out by negative 4.9, you're going to get a real mess of decimals. There's nothing wrong with completing the square, but you're going to have to do some rounding, which we really never did when we did complete the square. So I'm just going to take the shortcut in this case. I'm going to say, so we're trying to find the vertex. So the vertex, the value of t, or x, t is the x in this equation. The t coordinate of the vertex is negative b over 2a. That's our shortcut. So that's negative 92 from the b over 2 times negative 4.9. Okay, and if you do that math, you got 2 negatives, so it's going to cancel out. You're going to get 9.4, and this time I'm rounding it, 9.4 seconds. So that's when the maximum height happens, okay? So over here you could say, well, 9.4, this is when it happens. This hasn't given us the height yet, but now we can just use this time, like we did in question A, plug in the 9.4 and get the height. So now we want the, we're going to plug in into the equation. So we're going to get negative 4.9 times 9.4 squared plus 92 times 9.4 plus 9. Okay, obviously calculator required for this. Negative 432 is 432.964. That's what you get in the first term. Plus 864.8 plus 9, and that works out to 440.836. Haven't really rounded anything here. I'm just leaving it. And now I'm going to decide, like, how should I round this? You shouldn't make your rounding decision until you get down to the end, to the final answer. Otherwise, if you keep rounding and rounding and rounding, your answer could be off. So you should only be rounding once, and that's usually right at the end. Okay, so that's the height, and that's in meters. So let's answer the question. It says, what is the maximum height reached by the flare? So therefore, the maximum height reached by the flare. You notice I'm just repeating the same words back. Is, and now, or was, because it already happened, I guess. But that would be 440. And I'm going to round to 2 decimals. Like I said, that's as far as I would go, 0.84 meters. So if you go back to your picture, you could fill in this question mark now. You know the maximum height was 440.8. Okay, and you can see the scale is way off, but it does contain useful information. This is the point that we use to answer part A. This is the vertex, which we use to answer part B. Okay, next question. What is the height of the flare after 25 seconds? And then it says, does your answer make sense? So that's probably a little warning indicator that something might be wrong with this. So basically this looks like the same type of question as we had in A. We just plug in, instead of plugging in 3 seconds, we plug in 25. So let's go ahead and do that. So t equals 25. We've got h equals negative 4.9, 25 squared plus 92 times 25 plus 9. Oh, sorry, you couldn't see that. There we go. Okay, if we calculate these two, we get, this is going to be a huge number, right? And a huge negative number. Throws 3062.5. This is 2300, and that's 9. Put them all together, and we get this big negative number, negative 753.5 meters. Okay, so that sounds a bit weird, especially when we draw this diagram, because we've already said the height has to be greater than or equal to 0, and the time as well. So we don't accept any values down here. So what really happened here? Well, t equals 25 is, is like way over here probably. And, when we plug in that value for the parabola, it doesn't know what application we're using. It just knows, okay, where's the parabola at t equal 25, and it's like way down here. Okay, so that does not make sense, because in real life, when it hits the ground, which we don't know exactly what time, it looks like it's going to be, around 21 seconds maybe, because, halfway point here at 9.4. So at that point where it hit the ground, it just stays there. It doesn't keep going, doesn't drill into the ground. So basically it just stops and stays there. So even at 25 seconds after an hour, it's still at 0, even though the equation would tell you it's like extremely negative. because that's only looking at the parabola itself, okay? So you basically have to interpret this and say, well, hold on here, h has to be greater than or equal to 0. So therefore, h, the true value of h for this application will be 0 meters. Basically, it's on the ground. Okay, so you kind of you do the calculation, but you basically say like invalid, and we do this quite a bit when we do applications. Sometimes the numbers we get don't make sense in the context of the question. Okay, so interpret your answers, and that's why this sketch is so good, because it tells you, well, wait a minute, we can't have a negative height. The lowest the height can be is on the ground. So you have to interpret, and if you understand why you're getting this answer, that it's actually the parabola keeps going, but the ball doesn't keep going, or the flare doesn't keep going, it stops right there. Okay. All right, one more question to go. It says, determine algebraically the time for which the flare is higher than 80 meters. Okay. So, okay, if I'm looking at the picture again, and this is so valuable. Okay, so I'm looking at a height of 80 meters, so that's somewhere, somewhere between 9 and 240. So I'm just going to, again, the scale is not correct, but it's, everything's in the right order, and it's kind of telling you what you're looking for. So if I draw a line across at 80 meters, okay, and I know that the flare goes roughly that pattern there. It's launched below 80 meters. We know that it started at 9. We know that it went above 80 because it reached 480 meters. So if I look at the 80 meters, as the flare is going up, it hits 80 meters on the way up, keeps going up to the vertex, 480 meters, then starts coming down. It hits 80 meters again at some time after 9.4 seconds. And then it falls down to the ground. So there's two values, 2 times when the height will be 80 meters. So if I drop that down, I call that T1, and I call this T2. So basically, between these 2 times, between T1 and T2, the flare was above 80 meters. So I'm pretty sure I'm going to get 2 valid answers when I do it algebraically. Okay, so now I kind of know what I'm looking at here. I'm going to go back down and do this algebraically. Okay, so again, now what do I know here? I know that the height is 80 meters. Okay, so I go back to my equation, and I'm going to set the height equal to 80. So that means 80 is equal to negative 4.9 t squared plus 92t plus 9. And this is a solving equation. So we're not finding the vertex here, we're solving the equation. So we're gonna we can use either factor and solve, or quadratic formula and solve, and I almost always would recommend quadratic formula, especially when you have negative numbers and decimals, and the fact that not everything's going to be factorable. And pretty sure this case it's not factorable. But either method we use, whether it's factoring or quadratic formula, I need to have a 0 here. So I'm going to subtract 0 from both sides to make that a 0. And I'm going to get negative 4.9 t squared plus 92. And when I subtract 80 from this side, 9 minus 80 is negative 71. So now at this point, I've got my values of a, b, and c. A equals negative 4.9, b equals 92, c equals negative 71. I can now plug those into the quadratic formula and solve for t. Remember, I'm solving for t, not x. So t is equal to negative b, so that's negative 92, plus or minus leave myself lots of room. 90b squared is 92 squared minus 4 times A is negative 4.9, times C, which is negative 71. Okay, make sure your square root sign goes all the way across the top, and this division bar also. Make sure you've got enough room and it looks correct. Okay, on the bottom I've got 2 times A, and A is negative 4.9. Okay, so I'm just going to speed this up a bit. So I've got negative 92 plus or minus. Now, that's going to be 8464. And this one here, remember our little trick. So we count up how many negative signs there are. I've got 3 negative signs, so I know my answer is going to be negative, or a subtraction sign. And when I multiply those 3 numbers, 4, 4.9, and 71, I get 1391.6. And on the bottom, negative 9.8. Okay, and you can see, so I forgot, this should be 8464. Looked a little small compared to the other number, 8464. Okay, and when I do that and take the square root, I get negative 92 plus or minus. So I actually get like a 7072.4. When I take the square root, I get 84.10. I think it was 0.09, but rounded up, over negative 9.8. Okay, and then we're going to have 2 possible answers, and I'm hoping that they're both positive. When I do the negative 92 plus 84.1, and then divide by negative 9.8, I get 0.81 seconds, and I'm going to call that T1. Sorry, I've got a room here. So the first time when it hits 80 meters is 0.81 seconds, and you can kind of tell that's on its way up. It's very, very quick. And the other time would be negative 92 minus 84.1, and then divide by negative 9.8. This is actually 17.97 seconds. Okay, so if I relate this back to my little sketch at the top here, this is the first time. This is 0.81 seconds, and this is 17.9 seconds. So what I need to calculate, because it doesn't ask at what time is the flare at 80 meters. It says for how long is it above 80 meters. So what I have to do is find out how much time did it take to go from T1 to T2. Well, that's just a simple subtraction. So to get the time that it was above, you would do T2 minus T1, 17.9 seconds minus 0.81. That works out to 17.16 seconds, and that's our answer. Therefore, the flare was higher than 80 meters for 17.16 seconds. Okay, and that is the time over there. Okay, so get the whole picture in here. So that's how you would answer that. Providing that the height that you're being asked is, somewhere between the initial height and the highest height, the vertex, you should always get 2 valid values of t, meaning positive values of t, that are the solutions to the equation that you get. Okay. Now, so this is a good selection of questions. Now, it didn't ask one of the more frequent questions, and that is, when did the ball hit the ground? Okay, so if you're doing a question like that, when the ball hits the ground, you're looking for this point here. So what do you know about that point? Well, you don't know the time. That's what we want to find out, but you do know the height 0. Okay, so what you would do, it's a lot like it's a lot like the question we just did. Instead of solving for when is the height 80, we solve for the height being 0. So we just plug a 0 in here and solve, just like we did here. The only difference is our C value would be 9 and not negative 71. And you're going to get, again, you're going to get two answers. But for this type of question, you're going to get one answer that makes sense. Probably be something like 18 seconds or something. But the other answer will be negative, because if the parabola actually could go over here, the t value would be negative. So that t value would be invalid. Okay, when you're solving for when does the object hit the ground, you'll have one valid solution and one invalid solution. So I think we've seen those before, but that's how that works. The only other type of question I could think of that could be asked in a projectile would be, what is the initial height? And we've talked a lot about that. If you're looking for the initial height, that's when t equals 0. So you could either just say solve for t equals 0 and you're going to get 9, because these would be 0, zeros. Or you could just look at the equation and go, since the value of c is 9, the initial height is 9 meters. Okay, so projectile questions, very important, but in terms of difficulty, they should be lower, because first of all, you get the equation given to you, and the number of questions, the types of questions that can be asked are fairly predictable. Things like, what's the vertex, meaning what's the highest height that the object was at, what time or distance did that happen, when did it hit the ground, how long did it take to hit the ground, what's the initial height, and then more specific questions, how high was the object at a certain time, or how long was it above a certain height. So we've covered all of those. It's just organizing the information. The sketch, very, very important to kind of make sense of the question. There's nothing I hate more than just seeing a student just take the equation and blindly throw things in, hoping it works, without really understanding why they're doing what they're doing. You have to be able to relate what's going on with how the approach you're taking to solve this. Okay. All right. So that's another type of word problem. We'll probably be looking at another 3 or 4 after this. So now you can go ahead and look for the projectile questions on the booklet of 30 questions and start working on those. And after that, you can work on some of the other questions that we'll take up soon. Okay.